Alright, so today we are dealing with section 11.2, which we are talking about combinations. So combinations are very similar to permutations, so it's very important not to get them confused. So a combination is a selection of objects without regard to order. So that's very important for a distinction with permutations. So with permutations, order does matter, but with combination, it's a selection of objects without regard to order. So say for example, we had P, Q, R, and S, and we took a look at all the three-letter combinations. So here we could have PQR, PQS, PRS, and QRS. So according to combinations, these are the only combinations that we can actually have of those four letters. So say for example, we had PQR and RPQ. These, according to combinations, are the exact same thing. So order doesn't matter. We're using the exact same letters and order doesn't matter. So that means that those two combinations are actually the same thing. And the notation for combinations is pretty similar, once again, to permutations, except instead of P, we're going to have a C there. And also our equation is a little bit different, which we're going to take a look at it in a second. But we can also represent combinations using, in brackets, it'll be N over R. So one important thing is do not include that division. It's just N over R. And how we would kind of say this would be N choose R. So it'd be N total, and you're choosing R items. So this represents the number of combinations of N items taken R at a time, where R must be less than or equal to N, or N must be greater than or equal to R. So that's very important. You can't take R. If it's bigger than N, that's not possible. You can't take more than what you've already got. If you only have 10, you can't take 12. There's no 12 there. You're going to be short 2. And then also that R must be greater than or equal to 0. So remember, that's that restriction that we saw last section. So R must be greater than or equal to 0. And the equation that we use for this combination, or combinations in general, here we have subscript N, C, R is equal to N factorial divided by N minus R factorial. So this right here, if you guys notice, is a permutation, but what's going to make it different is that we're also going to add in this R factorial at the bottom. And we're going to have that same restriction that N must be an element of numbers. So it can't be decimals, can't be negatives. That's not what we're looking for. We want R and N to be greater than or equal to 0. Okay, so just note it's very similar to permutations, but we've only added this little guy down here, this R factorial, into the equation. So please do not confuse combinations of permutations. They're very similar, but they are not the same thing. So let's look at an example. So in our first example here, we have 8 female students and 9 male students are running for 6 offices on the Student Council Executive Team. So part A here, we are going to be looking at how many selections are possible. And so just to note, this is a combination question. It's not permutation because we're not looking at the specifics about whether or not a girl wins first, or if a male wins first. So the order doesn't matter. So here we're going to be dealing with combinations. And so we're going to be working with our combinations equation, which is NCR. So now we need to find N and we need to find R. So N is the total number. So what are the total number of people running for these offices? So here we have 8 females and 9 males. So adding those together, we get a total of 17. Then we need to find R. So how many people are actually being selected for this office? So we know that there are 6 offices, and this is under the assumption that it's 1 person per role. So that means we're going to be choosing 6 people. So now filling that in, if we want to use our equation, I'll just quickly rewrite this here. So we have N factorial divided by N minus R factorial times R factorial. And now let's fill in what we know. So we know N, so that'd be 17 combination, or 17 choose 6. That is equal to 17 factorial. Divide that by 17 subtract 6 factorial times 6 factorial. And then if you guys want to, you guys could actually put this into your calculators as it is, or we can simplify it, put it in that way, or we can just do this all by hand. It's up to you guys. So first let's put this into, let's simplify this bracket first. So that is equal to 17 factorial. Divide that by, so 17 minus 6 is 11 factorial, times that by 6 factorial. Now we can go a few different ways from here. From here, once again, you can put this into your calculator, or one thing that we can do is, and this could be applying from last section, we can simplify this 17 factorial to look like 11 factorial and then cancel out those common terms. So if you guys want to, from here, put this into your calculators, but if not, I'm going to show you this other method of simplifying. So let's rewrite 17 factorial. So that is 17 times 16 times 15 times 14 times 13 times 12. I'm just going to write this right here, times 11. And this is where we're going to stop. So then we'll do 11 factorial. So remember, 11 factorial would keep on going, which is why we can rewrite it exactly like that. That's 11 factorial there. And that's all divided by 11 factorial times it by 6 factorial. So from here on out, we can cancel out our 11 factorials. So cancel out those like terms. And what we're left with is 17 times 16 times 15 times 14 times 13 times 12. That's all divided by 6 factorial. Now if you kind of see that, that's a lot of work. But if you like it this way, go for it. But if not, we can throw this into our calculators as it is. And what you should get for your numerator is, we have 8,910,720. Divide that by 6 factorial, which is 720. Simplifying that fraction, we should get that there are 12,376 possible ways to select your office of 6. Alright? So there is combinations, so it didn't matter if we picked a girl first or a boy first. It didn't matter which order, as long as we had 6 people, that's all we wanted to know. So moving on to B here, this one here is asking how many selections are possible if the executive team must have 3 females and 3 males. So this one's going to be kind of going along the lines of when we did look at one example earlier in section 11.1 where we multiplied the different combinations. So this one is going to be along the same lines. So we're going to have 3 males. So we're going to find out that selection, and we're going to multiply that by the selection if there are 3 females. Okay, so first of all, we need to find what the combination is if we chose 3 males. So here we're using combinations. Doesn't matter which order we pick these 3 males in. And this one's really important. So we're only going to be looking at the population of our males. So how many males were there in total? So if you guys recall, there are 9 males in total. So our n is 9. And we're only choosing 3 of them. So r is 3. So plugging that into our equation there, we have n factorial, which is 9 factorial. Divide that by, it'd be n minus r, which is 9 minus 3. So it'd be 6 factorial. Times it by r factorial, which is 3 factorial. And then from there, I trust that you guys can put this into your calculators. If you guys are still having a little bit of issues with your calculators, please do come see me. Just make sure you might run into problems with BEDMAS. It'll probably want to divide this first, then multiply that result by 3. So just make sure you put brackets right here, so that way it divides this whole thing, okay? So if you guys hopefully you guys aren't having any issues with calculator work, but definitely come see me if you guys are, okay? So put this into your calculators, and we should find that our total combinations for 3 males is 84. Then we have 3 females, so we're going to go along the same lines there, except we have different numbers this time. So this one we know that there was 8 females, so that is n, and we're still choosing 3 there. So putting that into our formula, we have 8 factorial. Divide that by, it'd be 8 minus 3, so it'd be 5 factorial, times it by r, which is 3 factorial. putting that into your calculator, we should find that the possibilities for females is 56. Then from there, and note this isn't a case question, so we're not adding these two together, but we're going to multiply them. So this is going back to that very first question that we looked at, say with the menus in 11.1. So here we're going to be multiplying them. So there's 3 for males and 3 for females. So remember how we multiplied each of those together? Well, we found that this total here was 84 and this total here was 56. So we're going to multiply those two numbers. So that means that we have 84 times 56. If you guys put that into your calculators, we should find that there are 4,704 possible combinations or possible ways to have, I guess, a 6-student council executive team with 3 females and 3 males. So there's a bunch of different ways that we can sort out our females and males. Kind of crazy, but there it is. So now we're getting close to that 15-minute mark. I don't think we're going to have time to do our next question. So let's switch over to video number 2.